Hello and welcome to PCMINR.com, and in this video we are going to discuss the principle and working of an AC generator. So the working of an AC generator is actually based on the principle of electromagnetic induction. So you've already done the definition for electromagnetic induction, which says that when a conducting wire or a metal wire is moved in a magnetic field, a current is induced in the wire. So there is no current in the wire originally, but when it is rotated or it is moved with respect to a magnetic field, a current gets generated or induced in the wire. So for that, you can see here we have taken that wire in the form of a coil. So we take a coil here, and as you can see this side, so this is a coil, a rectangular coil being rotated within a magnetic field. So the magnetic field is directed from left to right, as we can see, and the coil is being rotated like this in the clockwise direction. So let us assume that like this is the coil, and we can mark this side or this arm as AB and this arm as CD. So in this coil AB, if it is rotating upwards, or we can say clockwise, right, we are assuming this coil is rotating clockwise and the magnetic field is directed from left to right, then according to Fleming's right hand rule, if you hold your right hand, you stretch your thumb upwards so that to show the movement of the coil towards or in the clockwise direction, and the forefinger that points in the direction of the magnetic field, then you would notice that the middle finger, which is giving the direction of current as per Fleming's right hand rule, would indicate the direction of current in the coil AB arm to be along this direction where I've marked the arrow. And now this side of the coil arm CD, it is going down. So that is going down means the force is acting in the downward direction. The magnetic field is still from left to right. So in the arm CD, the current will be induced in this direction as marked in the arrows. Now, we have seen that the directions of current in the two arms are opposite. But the moment our coil moves or rotates by 90 degrees and reaches in the vertical position like this, we see that now the coil AB has moved up, and because it has to go down to complete the rotation, so the force will be acting in the downward direction, and now the current in the coil will become towards this direction, and the arm CD, which was originally here, has gone vertically down, so the current in this arm will be in the opposite direction now, because the force on this arm is acting in the upward direction. Thus we can say that the currents, they interchange their direction. So now they reverse their direction. Now the same thing is going to happen when the coil will rotate completely by 180 degrees, and this AB will again go to the top. So we can say that after every half rotation, right, after every half rotation, that is by a rotation of 180 degrees, right? Half rotation is 180 degrees. So after every half rotation, the current changes the direction. That is why we are giving it the name of AC generator, because it is inducing an alternating current. So the current that is being induced here is going to be like this: up in one direction, reaches zero, then in the opposite direction, and so on. So this kind of a current, if this kind of a wave is generated, that is called an AC current. So after every half rotation, this thing will continue. Again the arm AB will go up, then again it will go down. Every time the direction of forces on the arms AB and the arm CD, they keep changing, and so the directions of currents also keep changing in the two arms. So we get as a result an alternating current induced in the coil. So you have to note down that every time the coil becomes perpendicular to the magnetic field, the direction of current changes. That's an important thing to be noted down. Now the next thing that comes up is, okay, fine, the current is induced in the coil, but now how are we going to use that current? How are we going to use this to run a load. So here I have a bulb connected here. So is it possible? Yes, it is possible to connect this bulb directly to the wires and it can start glowing. But don't you think there will be a problem that when this coil, because it's rotating, when this arm will go up and this will go down, these two coils will get tangled. And so to avoid the tangling of the coils in between among each other, we use the slip rings. Now how do these slip rings work? So here we see these are the slip rings. So these are complete rings, metallic rings, and we make the coil, the two arms pass through these slip rings. So one ring is attached to one coil and the other ring is attached to the other coil. So when your coil is rotating, they will not get tangled, but they will keep on passing smoothly between these rings. Now, how can we connect them further to the load? So here you can see we have the carbon brushes, right? So these are the carbon brushes which are just touching the slip rings. So the carbon brushes which are touching the slip rings, they develop the contact between the load and the coil. So the carbon brushes which are just touching, they touch the slip rings, and every time the current which is being induced is passed on to the carbon brushes, and through the carbon brushes it is passed on to the load. So carbon brushes touch the slip rings and the current which is induced in the coil, the induced current in the coil passes through the carbon brushes, right? It passes through the carbon brushes to the load. So carbon brushes, they don't interrupt the motion of the rings because they are not attached to the slip rings. The carbon brushes are just touching. So carbon brushes, the further they are just connected to the wires through the load, and this way you can utilize to run the load, the current which has been induced in the coil. So this is how the AC generator works. So it produces an AC current because of the rotation happening, and based on Fleming's right-hand rule, the direction of current induced keeps changing in the coil and the rotation is very fast. So we have a high frequency AC being generated. And to avoid any tangling of the wires or to make a smooth rotation by 360 degrees, the slip rings, they help us to continue a rotation of 360 degrees. And the carbon brushes, they help to develop the contact between the wires, the metallic wire in which the current is induced, and the wires connected to the load. So this is how an AC generator can be used, and how the rotation of the coil is happening, that for that it has been attached to a turbine, and the turbine can be rotated by any means. Like you have in a dam, the turbine is rotated with water which is falling at a high speed, or in the nuclear power generators we have the steam which rotates the turbine, or in the windmills it's the fast blowing wind which rotates the turbine. But that turbine, the purpose of the turbine is only to rotate this coil within the magnetic field, so that based on the principle of electromagnetic induction we can get an induced current in the wire. I hope the working of AC generator is clear to you, and if you like this video, you find it helpful, please like us, subscribe us, and follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.